Many of you were not interested in revision, right? I got, messages from many students saying that they don't want revision as such. So I'll start with a new chapter. Let's learn about polymers. Now, in today's world, polymers find huge applications. They are everywhere, right? Right from electrical insulation to the things that we use at home, buckets, toys, and cups, and this and that. Everywhere you'll see a particular polymer being used, especially packaging industry. You name it. A wide range of applications for polymers. Now, you have a very small chapter as far as your syllabus is concerned with respect to the classification of polymers, and then followed by some addition polymers, condensation polymers. There is various types of polymers that we use. Therefore, let's get the meaning of this word. What is meant by a polymer? Now, polymer, this name is coined from two Greek words. Poly, which means many, and mer, not company, okay? Mer means unit or part. Therefore, polymer is nothing but something that has many units, or that is made up of many units. So, suppose if you hypothetically, if you consider the wall as a polymer, then it is made up of a basic unit. What is that? Which repeats itself. It's a brick. So you go on repeating this brick, right? Like this, it goes on to get the wall, right? Therefore, a polymer is a large molecule, or you can say it's a macromolecule. It has huge molecular mass. So it's a macromolecule which is made up of repeating structural unit. A structural unit that goes on repeating itself. Or you can join many structural units together, and what results into is a large molecule called as a polymer. Therefore, by repeating the structural unit, and that structural unit which repeats is called as a monomer. So, a polymer is derived used by repeating the structural unit, the monomer. Right. Therefore, the process of getting a polymer from a monomer is called as polymerization. Okay, so polymer is defined as something that is created by repeating the structural unit monomer. Okay, process is called as polymerization. Fine. Now, after knowing the definition or the meaning of a polymer, let's go into the classification of polymers. Now, classification of polymers can be done in many ways. So, you get many ways of classification. The first is the methods of classification, we say. The first one is classification of polymers depending upon from where they are derived. Okay, from where they are got. Understood? Depending upon nature. So here, in this type of classification, we get three main types. One is semi-synthetic polymer. Third one is synthetic. Okay, so this classification is based on the source from where we get this polymer. So classification of polymers based on, let us write, based on source. So into, you can define, you can classify them depending upon or based on source as natural polymers, semi-synthetic, synthetic. Now what is this? If you get a polymer from nature or from a natural source, you have several of them, right? Cotton fiber is one, wool is another, right? These are all polymers that are derived from nature. Cellulose is another one. These are all polymers which are, got from repeating the structural unit demonomers, right? So if you derive that polymer from natural source, then it is called natural polymer. Okay. So starch is there, then cotton fibers, wool, all these are natural polymers. Then polymers made by man, right? So they are all synthetic. Understood? So we have several, like for example PVC, then polythene, right? Bakelite, several are there. Right here, best example is rubber. Here we have several. These are all man-made, which are derived by, they are all synthetic in nature. This means they are created in the lab or using industrial processes, etc. So I can say they are derived by man, or man did them, or man created them. So they all come under synthetic polymers. Okay. Then we can mix this and this. We can mix natural polymers with synthetic polymers and create the third category, which is called semi-synthetic. Neither fully natural in nature, neither fully synthetic in nature, but by mixing natural with synthetic, you can create a third category that is called as semi-synthetic polymers. So rayon is a very good example. Then you have, okay, very good example where it is semi-synthetic. That is, you can use cellulose with cellulose nitrate. You can use cellulose acetate is there. These are all semi-synthetic. So classification of polymers, I told you, can be done on the basis of many things. Okay. So one is based on source. Based on source, we get three types: natural, that is, the origin is from nature; synthetic, which are created by man, in the lab you can say, or in the industry you can say. Then we can combine natural with synthetic to get semi-synthetic. This is the first and the simplest classification. The second classification is based on their structure. Okay. So there also you get three types. First one, linear. Okay. Second one is branched. Third one, cross-linked or network. Okay, so based on what structure they have, we can classify the polymers into again three types: linear, branched, and cross-linked or network polymers. Linear polymers means the change, the polymeric, the polymer chains will be linear in nature like this. So if we have long chains, okay, almost linear in nature, if this is the structure, then they come under linear polymers. But if it is branched, what happens? There will be a branching here and there. There will be a joining of those particular polymer chains. Okay. So branch structure will be something like, if this is one chain, this is another chain, there can be a linkage somewhere here, there can be a linkage somewhere here like this. Here and there, they will be linked with one another. Then it becomes branched. The structure becomes branched. So they are called as branched polymers. Cross-linked means they can be made up of, there can be chains of bifunctional and trifunctional monomers which are joined together, and they will be connected at several places. So therefore they are called network and cross-linked. So in branch, what happens, here and there will be a linkage between two linear chains. But in case of cross-linked, the linkages will be many. So one chain is connected to another chain through a covalent bond. Therefore, the structure, if you see, so if this is one chain, this is another chain, this is the third chain, this is the fourth chain. So here there is one, here there is one, here there is one. Similarly, here there is one, like this. So extensive branching, you can say, is there in case of cross-linked. So if you have linear chains of polymer chains, one after the other, running one after the other, then they are called as linear polymers. But if the same chains are branched here and there, then you get a branched polymer. So there is some connection between the two polymer chains. And if there is extensive linkages among the polymer chain, then you get a cross-linked or network polymer. So depending upon the structure or based on the structure, polymer can be classified into linear, where you will have linear polymer chains. The structure is straight chains are there of polymers. Then branch means here and there will be some links between the chains. And cross-linked means there will be extensive linkage between the two. So this is second classification of polymers. The third polymer classification I told you, the process of getting a polymer is called as polymerization. Basically, there are two types of polymerizations. One is called addition, okay, which is called chain growth polymerization also, where we go on adding or repeating the structural unit, the monomer, okay. Then it is called as the addition polymerization. So based on the type of polymerization, you have two types of polymerization processes. One is addition polymerization, second one is the condensation polymerization. So in addition polymerization, what we do, we go on adding the monomers, and basically the monomer should have a double bond or a triple bond. Okay, so you can go on adding it. Best example for addition polymerization is your polythene, whether it is low density or high density polythene. So what we do, we start with huge number of monomeric units. And what is that? We start with large number of ethene molecules, N number. We make them polymerize. So let them undergo polymerization and we get the basic unit. We get a basic unit CH2 dash CH2 n number we get. Now you take this monomer and go on adding them one after the other. So that you get the polymer, that is polythene. So we will get CH2 dash CH2 n number. This is your polythene. So this is addition polymerization. Okay. Then if you want, you can also take Polymerization for example. That is butadiene styrene polymer. So what we need? We need butadiene. So this is 1,3-butadiene. Okay, so this is 1,3-butadiene. And you can add styrene to that. This is styrene, right? So you can add them. So you get a polymer called as the butadiene styrene polymer, or simply called as BONA-S. N number of times. Okay. So this particular monomeric unit repeats or goes on adding one after the other to get the polymer BONA-S. So this is called as the addition polymerization, or we get an addition polymer. So polythene is an addition polymer. BONA-S is also an addition polymer. Okay. Here we are using the same type of unit. Same structural unit you have. The monomeric unit is this. This goes on repeating. Whereas here we have two. One is butadiene, another one is styrene. We add that together. We get this monomeric unit, and that repeats n number of time, or adds on n number of time to get your polymer. Right? So by addition of substances, normally which have a double bond or a triple bond, you can create a polymer, and then it is called as simply going on adding one after the other. Then it is called as addition polymerization. So this polymerization is based on mode, we say. Based on type of polymerization, or we call it as mode of polymerization. Is the correct word? Based on the mode of polymerization, we have first one addition polymerization, second one is condensation polymerization. In condensation polymerization, what we do? We combine two things by elimination of a water molecule or an OH group, or something like HCl can be removed. So you combine two things by liberation of a water molecule, normally is called as condensation. So joining two things by liberation of a water molecule becomes condensation. Therefore, Second class of polymers is condensation polymers, where we join two monomeric units by condensation. So best example here can be given nylon 6,6. It's a good example for condensation polymerization. So you can take with hexamethylene diamine, okay. To this we will add adipic acid. Okay, so what we'll do, let's write this as H, here there is H, right? So this particular H and this OH can be removed in the form of H2O. So if you remove that in the form of H2O, so what do you get? You get NH, alright, NH dash CH2 dash CH2 6 times dash NH. What remains here? NH, then dash CO, C double bond O, dash CH2 4 times dash C double bond O. So this becomes the monomeric unit that repeats n number of times. So that is your nylon 6,6. So this is an example of condensation polymerization, where we are combining a molecule of hexamethylene diamine with adipic acid by removal of one water molecule. So based on the mode of polymerization, this is the second class we get, condensation polymers or condensation polymerization. Okay. So now we have seen three types of classification. First one based on source. So there you have natural, you have synthetic and semi-synthetic. Then the second classification was based on their structure. There you had linear, you had branched, then you have the third one, cross-linked or network polymers. Then the third classification based on mode of polymerization. There you have addition polymers and condensation polymers. Right? One derived by adding monomeric units, that's addition polymerization process. Second by combining two units with the liberation of a water molecule or a OH group or an HCl molecule, etc. Then there is a fourth way of classifying the polymers, that is based on what type of intermolecular forces of attraction exists between the monomeric units. So based on intermolecular forces of attraction. That can hold the monomeric units, right? Because depending upon what type of force of attraction exists, that will give other properties, or the other properties like strength, modulus, tensile strength, their stretching qualities, all those things, all those properties they depend upon what type of force holds the two units together. Okay. Here, the first one is, here we get almost four types of polymers. The first one is elastomer. So, elastomers have stretching property. They can be stretched, rubber, can be stretched. So they have, you can say, they have rubber-like properties. So they can be stretched. Right? When can substance be stretched? It can be stretched only when the intermolecular forces that are holding the monomeric units is not that very strong. Okay. So in case of elastomers, there is a weak force of attraction. Okay. So that will hold the two monomeric units together. So because of this weak force that is there, what happens is they get the stretching property, or you can say qualities. You can stretch them a little bit. So they will stretch and come back to their original position. So all these polymers, if they have this quality, you should know that the force of attraction is not very strong. It is a weak force of attraction that exists in this, but in this polymers. So whenever intermolecular force of attraction is very weak between, or it's a weak force between the two monomeric units, that leads to a class of polymers called as elastomer. So neoprene is a very good example. Neoprene. Even Bona-S can be a very good example of elastomer. Okay. The second one is fiber. Or fibers we call them. These are very strong in nature. They have very high tensile strength. They are very high modulus. So you cannot stretch them as you can do for elastomers. They are very strong in nature because they are made up of linear fiber-like. One after the other. The structure is something like this. Very linear, very strong. So the reason for that is there is a very strong force of attraction that exists between the monomeric unit that gives the extra strength. They are very strong in nature. So they are quite opposite to elastomers. So fibers and elastomers have almost opposite qualities. Okay. So these are very strong. The very reason is the force that existed here was a weak force. Here there is a strong force that exists that holds the monomeric units together. Because of that, enhanced properties will come into existence. Okay. So this is with respect to the fibers. So nylon 66 is a very good example. Nylon 66 is a very good example for fibers. Then comes the thermoplastic. Thermoplastic polymer. And the fourth one is thermosetting polymer. Okay. So these are the four polymers. So this two I will explain in the next class. Okay, thank you.